This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. Okay, so let's have more examples on a 4-variable map. Okay, so we have here, draw the simplified logical circuit for the following equation. So this is for number 1. This is our logical equation. And we want to use K-map to simplify this logical equation so that we can arrive with a simplified logical circuit. So, the first step again is to make a map. Okay, 16 cells. Okay, so the inputs are A, B, C, D. The values of your variables are 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And we know that this belongs to A bar. This area here belongs to A. This belongs to B. And this one here is B bar and B bar. Then you have C, C bar. And then you have D, D bar, D bar. Okay? Then we locate these equations into our map. So, we have A, B, C. That is 3 variable term equivalent to 2 adjacent cells. So, where can we locate A, B, C into our map? So, you have A, these 8 cells. Then B, it is in these 4 cells. And then C, where's C? These 2 cells here. So that is the intersection of A, B, C is A, B, and C. These 2 adjacent cells. So you place 2 ones there. And then you have A, B, C bar D. That is a 4 variable term that is equivalent to 1 adjacent cell. Where is it located? So you have here A, and then B, and then C bar, and then D at 1. So it is located there. And then B bar, that is a 2 variable term, represents 4 adjacent cells. So where is it located? So you have B bar here, and then at the same time D bar. Where's that? That one. So B bar, D bar. That will be this particular cells. In other words, these 4 cells here are adjacent. Ano man? Because again, if we fold this one there, mag-abot na yung apart, o kani, and then we fold this one here, going there, 4 of these cells now will be connected together, and they are adjacent. No? So, more or less, murag gawa siya nga 4 adjacent cells in square. Okay? And then, we have A. Where's A? This one. 8 adjacent cells. So, some of the cells have already a value of 1. So, we just put 1 on the blank cells. This is under A. Okay? Then we have B bar, C bar, D bar. That is a 3 variable term, which means you have 2 adjacent cells. So you have B bar here, 8 cells, and then C bar here. So that means that these 2 cells, 4 cells here, and then D bar. Where's D bar? This one. Okay, so we have already 1 here and 1 here, so no need to place another 1. Then we have A bar, B, C, D. That is 4 variable term. That means that 1 cell. So you have A bar, B, C, D. 1. So you put a 1 here. And then you have A, D bar. That is 4 adjacent cells. A, and then D bar. Where's D bar? This one. So you have this one and this one. So you have already a 1 in that particular location. So we have already represented our equation in our map. So the next step is for you to group the cells which are adjacent together. Again, what is the grouping? 16, 8, 4, 2, 1. Okay? So there's no 16 adjacent cells here. So we go to 8 adjacent cells. So we have here 8 adjacent cells. This one. Okay? There. We have 8 adjacent cells. And then next is 4. There's no more 8, so we go to 4. 4 adjacent cells. Which one is adjacent? This one here and this one is not yet grouped. So this cell here and these cells here are adjacent together. Now, as I've said, why are they adjacent? When you fold this there, these two part here, this one and this one are adjacent, and then once you fold it there, this 4 here becomes adjacent. Okay, so that will be our grouping. These 4 adjacent cells are, these 4 cells are adjacent. Okay? Then, no need to group this one because they are already grouped into one adjacent cell. Because once you group this again, it becomes a redundant variable. Okay, next is, wala na 4, we go to 2 adjacent cells. So this one here, the remaining one here which is not yet combined, we find a particular cell which is adjacent to this particular cell, and that is this one. Okay, so we group this one and this one as one cell, one group I mean. Okay, so everything is already grouped. Then we obtain the logical circuit equivalent. So for these 8 adjacent cells, this belongs to A. And these 4 adjacent cells, this one belongs to B bar, and at the same time belongs to D bar. Okay? And this group here belongs to B, at the same time belongs to C and D. So that will be our equation. So we just use the sum of product expression. What will be our final equation? So we have B bar, D bar, plus A plus B, C, D is equal to X. Okay? And so the logical circuit equivalent, simplified logical circuit equivalent will be, you have here an AND gate, B bar, D bar, then you have B, C, D, okay, and these two are being ORed to A. So you have here A. So the output is X. That will be our logical, simplified logical circuit.